Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at register variables. Today, we're going to be looking at one of the compiler directives within PowerBasic, namely the register. So we're going to create a demo program here to try this out. One of the things that the PowerBasic program does for you is it does create very small and very fast executables. One of its techniques for achieving this is to use the processor registers. What we're going to do in this program is very simple. We're going to do a for next loop and we're going to increment a variable inside that loop. So we'll create a couple of variables to do that. And we will create our for next loop. And this is a very simple little function here. All it's going to do is going to take the long R variable and run it through 10,000 iterations. And for each iteration we're going to increment the long count variable by 1. Now, one thing we've done in previous videos is we have measured the number of clock cycles it takes to actually execute this command. So we'll use that command in here and we'll create a quad size variable to handle that. And we will use the ticks command to start the count. And at the end of the for next loop, we will stop our clock running and we'll know how many cycles we've actually used up. And so we know how many that is, we will output that to our log. What our program is going to be doing, once it's iterated through 10,000 iterations, it will then throw out to the log how many clock cycles that has actually taken. So if we run our program now, we'll see that the program is reporting we used 8,892 clock cycles. That's pretty efficient. So now we have a baseline for how your program would normally behave. What we're going to look at is the register command. The register command is a compiler directive. If we have a look at the help, we will see that the default, if you don't use the command at all, is to request automatic allocations of all integral class variables in all cases and extended precision floating point variables located in your subroutine or function. Now what that actually means is that you're allowing the compiler to decide which variables to store in the CPU's registers. So if we turn this off and make sure that there is no enabling of automatic assignment of register variables, we'll see the difference that makes to our program. So we've not changed any of the code, we're just telling it not to use register variables. So if we run that now, you'll see that the number of clock cycles it takes to execute the program has gone up considerably. If we run that again just to see if it's changed, still around 17,000. Now there may be times you want actually to use the register none so that you can specifically within a particular subroutine decide which variables are actually going to be optimized. So we'll comment this line of code out for the moment and we'll put that inside the function. So if we run that now, we would see we will get exactly the same 17,000 clock cycles. In order to make our program run faster, we can decide which variables are going to be stored in the registers. So we'll try first of all the for next loop. Just by replacing the local word with register, we are instructing the compiler that when it compiles that the long R variable is to be stored on the register. And we're back to 8,892 clock cycles. So any subroutine or function, if you're using a large number of variables, and several of them are being used for for-next loops, you can selectively pick one or two of the variables to be used on the registers, thereby speeding up your application. So if you have perhaps a for-next loop of 1 to 10,000 and another for-next loop of 1 to 10, obviously the one to go for is the one with the biggest number of iterations. We can also change our count to use register and run that one, and we'll see the program is much the same length of time. We haven't gained anything. If we change it so that the long R is using a local and the count is using a register, then we still see the performance gain. So looking at the help file, you'll find there's information within the help file that will guide you when is the best time to actually use these. Since PowerBasic is a 32-bit application, you're better using long variables rather than integer variables. It can actually take PowerBasic longer to process integer variables than it does long variables. So there's probably no reason anymore to use integer variables, especially for for-next loops. At the moment, within PowerBasic, register variables are always local to the subroutine or the function in which they appear. In the current version of PowerBasic, you can have up to 2 integral class variables and up to 4 extended precision floating point variables, which are using registers. There's nothing to stop you defining all of the variables in your function as being register variables. However, you're then leaving it up to PowerBasic to assign the first 2 it finds to the registers. So using the register command, and with a little care, you can actually speed up the application that you've been writing. But that's it for today. Thank you for watching.